Ladies and gentlemen, we are very lucky to have Alphabet X with us, and its chief of Moonshots, Astro Teller, who has created an incredible innovation lab, and he's going to share with us some of the secrets to how X is applying AI in very practical ways to create game-changing solutions to very big problems. Astro, could you join me on the stage? Thank you. It's there. Great to see you. To begin with, could you just briefly recap for us, how X, which was founded in 2010, operates within Alphabet?
Sure. So X is Alphabet's moonshot factory. And what that basically means is that our product, the thing that we're supposed to make for Alphabet, is not things per se, but businesses. So when we create Waymo, the self-driving car group, see, I told you I was going to do that, and hand that to Alphabet, that's us delivering our product to Alphabet. When we create Verily, the life sciences group, as a new Alphabet entity, that's us doing our job and saying, here's a business, a potentially Google scale business for Alphabet to have.
Got it.
Google Brain, which has been part of these conversations yesterday and today, came from X originally. Now, in that particular case, we graduated it back to Google rather than setting it up as an independent entity. But that's our job, is to do these sort of potentially Google scale, over-the-horizon kinds of things.
Got it. Fantastic. And now you've been working with AI for quite some time. In fact, you have a doctorate, I believe, in AI from Carnegie Mellon. Is that right?
Guilty.
Guilty as charged. Excellent. There's a lot of hype around the technology right now. You've seen this kind of arc, and there's been false dawns of AI. I mean, do you think where we are now is like, this really is it?
No.
Oh, OK.
Sorry.
Well, then we'll...
we can pack
next interview candidate, please. Thank you.
Look,
OK.
We have these hype cycles, and it is very real that machine learning in particular, AI is much bigger than just machine learning, but machine learning in particular is on a big upswing. That is, to some extent, about the algorithms, to a larger extent, Moore's law and the prevalence of enough of the right kind of sufficiently clean data has gotten us to the place where we have gotten some qualitative improvements. We still have incredibly siloed solutions. And so, yes, looking backwards, we are on a very steep ramp. But we are not in danger of having sort of dusted our hands off and declared victory on general AI in the next 5 years.
Got it.
I think that that's premature to imagine sort of Terminator scenarios, positively or negatively. AI is still very much a work in progress.
OK, so it's a work in progress, and it's a work in progress at X, right? I mean, maybe you can talk about some of the practical areas that you've been using AI. And I know you have like kind of one graduate, which is Waymo, the driverless cars company. Remarkable technology. And clearly AI is like at the heart of that. There's obviously a lot of discussion right now around driverless cars, given the Uber accident that happened recently, very unfortunate accident. How should we be thinking about AI in the context of transportation, and what does that event mean for us?
Let me give you a couple examples of things that are sort of close to X's heart, using AI in targeted but important ways for the projects that we have. And understand, while we have occasionally, like Google Brain, done work where we describe the work itself as working on machine learning or AI, for the most part, machine learning, artificial intelligence is like saying, hey, we got electricity in our stuff. Hey, we have transistors in our projects. Yeah, so do we, Astro. So I think to understand X is partly to understand that we take machine learning incredibly seriously. Hopefully we're pushing some of the envelopes and boundaries of what machine learning can do, but we see it as an enabling technology and not the point of what we're doing. Let me give you some examples. Waymo, there are lots of parts of Waymo that are hand-built, but there are things that are just not really hand-buildable. As an example, when you have a bicyclist next to you on the road and their hands are kind of waggling, are they signaling or not. You know, people move their arms when they're on their bicycle,
Right.
but it is a legal requirement for any driver, including an automated driver, to be able to tell the difference between I'm going to stop, I'm going left, I'm turning right. And there's a lot of different ways that people can do this, and they're somewhat sloppy about it, the bicyclists. And handwriting code that describes, aha, that's a left turn signal, is more or less not doable, but we have to do it. This is a good example of machine learning being able, with lots of very carefully labeled examples by humans, to come up with algorithms that can correctly determine
Right.
when someone's just waggling their arms and when they're saying, I'm actually intending to turn right soon.
Right. But are you saying the technology is still kind of like, it really isn't quite there?
No, it's absolutely there.
Oh, it's
I'm saying that is something where we couldn't hand build it, and we do a great job of it, and the reason that we do a great job of it is thanks to machine learning.
Got it.
Let me give you another example. When Wing, which is our self-flying vehicles for package delivery, which is ramping up a business in Australia, when they fly to someone's house, so you say, I want something from, let's say Chemist Warehouse in Australia, you need some Advil. You could tell the system, here's where I want you to drop it off, in your backyard, let's say. But most people aren't going to do that. So one of the many things that Wing has to do in order to be safe and effective and useful is figure out where it can leave the package for you.
Right.
So is that a driveway or is that a street? Because we can probably leave the package on the driveway, but we can't leave it on the street. Is that your backyard? I think so. Or is that somebody else's backyard? Is that a trampoline or is that a pool? Because we could probably leave the package on the trampoline. That's maybe not ideal, but fine. Leaving it in the pool's not so good. Leaving it on the top of a shed might be bad, but leaving it on top of your roof of your house would be really bad. So where exactly can we leave it? And figuring that out from satellite imagery and from 3D terrain data from these sort of flyovers that planes do sometimes.
Right.
So using that data, how would you as a human coder write an algorithm that's going to correctly pick for every home in Australia where it's okay to leave that package? Not doable. But we have to do that. And it's working quite well already, thanks to machine learning. So that's a very concrete example.
And so how does it work? I mean, it's
Right.
like, what are you using? So you're using machine learning with the drone, it's combining the vision,
Yes,
the
so
cameras
it
from the
uses
drone as
things
it gets
like
close.
the satellite imagery and the 3D terrain data, and we
And
have
the vision.
humans who are picking where we think it should go. We use the fact that sometimes we say, we think we're going to go here, and then the user says, go here instead.
Got
Now,
it.
maybe that's a preference, but whether we're learning, no, please don't put it in my pool, or fine, my backyard would have been okay, but I'd rather you put it in my front yard. Either way, that's a useful labeled example for us. So between us labeling the data and the users labeling the data, the more and more of that data that we get, the better we can get at putting the package somewhere that's useful and safe.
Got it. And I just read recently that the FAA here is actually thinking of changing the rules so that drones might be able to sort of deliver stuff. Hopefully Wing might make it to the US at some point?
Sure. We would love
Commercially?
to. Yes, exactly. We are already doing quite a bit in the United States. We would love to do more, obviously, as the regulators in the United States decide that they want that to happen. We would be very happy to do it here.
Perfect.
Let me give you one more example,
Sure.
just to sort of give you a flavor of how our projects, our moonshots, are not machine learning moonshots, and at the same time, in lots of ways, they couldn't happen without machine learning. So Loon, which is our connectivity moonshot, how to get connectivity to the 3.5 billion people on the planet who currently have little or no internet connection, using stratospheric balloons. So if you leave a balloon up in the stratosphere with sort of like a baby cell tower underneath it, the winds would just whip it around the world. And it's been an open question for us for a long time. We know we can't fight the winds. You can't have a propeller on this thing that goes so fast that it fights the winds. But it doesn't take very much energy to go up and down relative to fighting the winds. And so if you could be super smart about which winds in the stratosphere, which is stratified, are going at different directions, at different speeds, at different times in the future. If you could predict that out, then like a game of chess, you could go, okay, I'm going to go up, and then I'll go over, and then I'll catch a wind going this way, and I'll go down, and I'll catch a wind going this way, and you could actually start to do loops without actually having to fight the winds. Now, that was a hypothesis from 6 years ago. But there was no way that a human was going to do that level of weather prediction and that level of chess playing, because we're not only doing that for a single balloon, but for many, many balloons. So we say, oh, I wish as a balloon I could get over there. No, I can't do it. Hey, buddy, this balloon, could you get over there? Wow. Yeah, I could. Okay, fine. Well, where did you want to go? So it's a very high-dimensional problem to solve.
It's balloon air traffic control.
Exactly.
Talking to each other.
That navigation using this sort of sailing the winds that our balloons are doing is now working well enough that when Puerto Rico lost its internet connectivity last fall, Loon was the ones who turned the internet back on for Puerto Rico, and that was entirely thanks to machine learning. If we had still been sailing all the way around the world as our balloons used to do, there's no way that like passing occasionally over Puerto Rico would have been very useful to the Puerto Ricans.
Right, yeah, one rotation. How many loons are up there now? I mean,
we're still, on the order of, tens of launches a week. It's not
tens of launches a week.
Yeah, so it's not a huge number because we're still testing a variety of things. They stay up for a long time now, well over 100 days. I think our record is about 200 days for a balloon, and that record continues to go up. But we're still in the phase where we're just growing out our capabilities in various ways, working with our telco partners on which parts of the world we should turn on next.
Really? Okay. So, you've had a lot of experience here with applying machine learning. What kind of recommendations and sort of learnings would you share with the room, the audience here, who themselves may be trying to apply machine learning in their businesses?
Well, I assume that this will be totally obvious to the half of the room which are already practitioners. But for those of you who are here because you'd like to become practitioners or because you're hoping to hire and use practitioners, the two things that I worry about when I hear people getting very excited about machine learning. Number one, it is a fiction that you can just throw machine learning or even machine learning people at a problem and get something done. It just doesn't work that way. If you don't understand your problem well, you may be disappointed with the results. And number two, even if you have world-class machine learning people and you have a problem which is really amenable to the machine learning, you still have two significant, somewhat related problems. Problem number one, without domain expertise, you will accomplish nothing. Absolutely nothing. The idea that there's some kind of API where you can have machine learning people over here and the domain over there, and they just don't really need to know about the domain, it just doesn't work like that.
So kind of machine learning as a service, not...
Maybe someday, but the issue is that especially the way machine learning is making the most progress today is very oriented around lots of data.
Right.
And garbage in, garbage out.
Yeah.
If you don't understand the domain, then the problem that you're handing to the system to learn in the form of bad data because you don't understand the domain and the nuances of the data and how that relates to the domain and the problem you're solving will cause the system that you learn to not function well in the real world.
Right.
So you both need a lot of data and it needs to be cleaned and organized in the right kinds of ways. And this is a big challenge for X that we spend a lot of time trying to get things that are in the physical world to work much better using machine learning. But unlike the sort of pure digital world, we can't just create arbitrary amounts of data.
Got it.
That's a big challenge for us, as you might imagine.
Absolutely. No, I get it. Are there other areas? Looking ahead, we talked about Wing and Loon, they've taken off. Where are we going to be using, where are you going to be using AI in future? Where do you see new opportunities for machine learning?
Sure, that's a long list, not a short list, but let me give you two examples that we haven't talked about. One that we just announced and one that we're excited about now. Again, there's lots of them. So we just announced a cybersecurity project, which we've been working on for several years. We announced it in January, but at the same time we announced that we were graduating it and setting it up as an independent Alphabet entity. And we think...
This is Chronicle.
This is Chronicle.
Right.
And we think that we have a real shot at building a much better immune system for the digital world,
right.
Using, not just, but certainly in large part, machine learning to do the kinds of detective work that right now humans are tasked with doing in order to figure out whether, once something is inside your network, that's probably not good. Right now, that's humans who do that. And that is super asymmetric warfare between the good guys and the bad guys, and the good guys are losing. And the only thing that's going to change that is machine learning. So that's an example that we're really excited about, that we just announced recently. I've been saying for years that agriculture, food production, I mean, look, that's one of the biggest industries in the world. It's one of the least digitally enabled, technology-enabled industries in the world, and it's one of the rate-limiting steps for humanity. So it has been true for a long time that X is like, we have got to do a moonshot, maybe several moonshots in this space. And recently, we've started to make more progress in a couple different areas, and that is thanks to machine learning.
You haven't mentioned this before, right?
So I've mentioned agriculture.
Agriculture you have.
Is interesting,
machine learning.
But we are finding more and more ways to help in various parts of the very complex food production agriculture system.
Massive.
Yeah, and we aren't determined, we've figured it out, we're done, we'll announce it next week. It's not going to roll like that. But we have several really interesting early things in this area, and actually having now sort of gotten a couple threads that we're pulling on successfully, it's actually encouraging us to place some more small bets in the area, spend more time out in the field with farmers so that we can understand their world better so that we can help them better.
Interesting. Can you give us any kind of like insight, hint into what they might be, those things?
Sure. So I'm going to give you examples that we're not specifically doing.
Okay.
But I'm going to help you understand the kinds of things that are exciting to us. Mm-hmm. So imagine, 1,000 acres of tomatoes. Right now, you have an expert, the farmer, who understands those tomatoes, who understands things like what mold on a tomato looks like, who understands if the tomato is ripe or not, if the tomato is going to need to be picked in 3 days or in 10 days. But that farmer cannot walk 1,000 acres every day. They just don't know what's going on in a lot of their fields. And this leads to a lot of inefficiencies, which is not because the farmers are dumb. It just doesn't pay for the farmer to get better than 2 or 3 days off from the perfect time to pick the tomatoes. They just have to guess because they can't walk the fields. But there is a significant food waste that you could solve if you could somehow magically know the optimal time to pick the tomatoes, having walked all 1,000 acres of all of those tomatoes. Well, doing, with drones or with something that rolls around there, maybe you could. If you have a tiny bit of mold on a small, small fraction of your tomatoes, you could ruin a very large fraction of your crop. Right? But where is the mold? And even if you knew where it is, how do you train people who don't know that that's mold to watch out for it or to go solve the mold in a very targeted way? Right now, we still carpet bomb fields with pesticides because in principle, you could find the pest and go psh, psh, on the pest right there, but that's too labor intensive. These are all examples that have perception, mobility and navigation, and maybe some actuation that would amplify the expertise of farmers if you had intelligent systems that could do that. Those, by and large, don't exist today, but I think that those are exciting examples. Let me give you a sort of different class of example, which is sort of decision support tools. So the easiest one is sort of, you grow soybeans and I grow soybeans, and as a result, the value of the soybeans for both of us is lower because we just grew too many soybeans. Whereas if we had somehow talked and coordinated, you grow the soybeans and I'll grow guar gum or something else, and then we'll both make more money. But it can become a lot more subtle than that. If there's sort of a pest, sort of flying insects that are hundreds of miles away. There are specific crops that if I knew that they were coming, I could grow these sort of like fake crops. I don't care about them, but they are what the pests will end up eating, and it will largely protect my crops. But how do I know that I'm about to have that infestation in a week?
Right.
So there's a lot of decision support tools for farmers that is also potentially transformative in that space.
And I suppose with things like climate change, it's become ever more harder to sort of predict weather patterns and all these kinds of things. So could machine learning contribute there too?
Yeah, absolutely. An example that we announced, that Alphabet announced a little bit more than a year ago, was DeepMind went into our own data centers, into the Google data centers, and tweaked parameters on how we were cooling our data centers and reduced the cost, the energy consumption of cooling our data centers by 40% without actually changing anything physical, just tweaking the parameters of it, which is, and these are very smart people who are running the data centers, and that's still a huge win for Google. Imagine irrigation in the fields as an equivalent to cooling in the data centers. It's not that the farmers don't understand their fields, but just like our data center folks could still get this huge benefit from those parameter tweaks that DeepMind helped them to find. If we could help, if somebody could help farmers tweak their irrigation to get either more water to the right plants at the right time, or get the plants the same amount healthy but using 40% less water, since water is often the rate-limiting step for the farmers and is the single biggest issue in terms of the carbon footprint of the foods that we end up eating, that would be transformative for agriculture.
I saw a statistic, I think it was from the Food and Agriculture Organization, the UN, that something like 20 to 40% of global crop yields are wasted every year because of pests and disease. So if we could get like a targeted AI pest terminator, that would be fabulous. Not the other kind of terminator, but the targeted pest terminator would be amazing. Ladies and gentlemen, I'm going to open to the floor in a minute, so if you could think of questions for Astro. I just wanted to very briefly come back to Chronicle. I mean, there are a lot of other companies out there trying to use AI for cyber defense. I mean, to me, it doesn't seem that kind of differentiated. What is different about Chronicle? Is it something because of the scale of Alphabet and the insights you've had about attacks coming into you, that you have a better grip on this than others?
So I know that it's been somewhat frustrating for people that we haven't been as specific with about Chronicle. And its secret sauce as we have in other areas. It is cybersecurity.
No one is going to tell anyone.
Yeah,
Don't worry.
But it is cybersecurity, so just be a little bit patient in this one specific case with us. There's a level of detail that we don't want to go below because
Fair enough.
That would give
the bad
guys some additional information. There's just no reason to give it to them.
Fair
so
enough.
I concede the point that without giving you that information, it's hard to tell exactly how useful it will be. So let's just say for Chronicle, time will tell, but I'm very bullish that they're going to have an exceptional run of it.
Okay, perfect, thank you. So I'd like to open to questions from the floor. We have runners with the mics. I think there's one question back there.
For the package delivery use case, why wouldn't you just issue the customer some sort of homing device that they can put on the property, kind of X marks the spot, if you will, to supplement the machine learning?
Sure, so we've looked at that. Other groups have too. You can do it quite inexpensively, but I mean, unless you just make a piece of plywood with an X on it, which tends to get moved around, it's a little complicated and makes your yard a little uglier. And even that has some cost that people don't necessarily want. So, it's X's attitude overall that our job should not be figuring out how to get society to change what it does to make our lives easier. We should do the opposite. Look at the self-driving cars. People not only have been, but are still, unbelievably, talking as though the world's infrastructure is going to change to accommodate self-driving cars. Here is a secret for you if you don't know. That is not going to happen. All the special lanes and hyper-platooning, and it's never gonna happen. That's just not how the world works. The infrastructure is very expensive, it's already been put in place, and anyone who's serious about self-driving cars is going to need to acknowledge that the cars are going to need to do what humans do and do it at least as safely as humans do it if they're gonna be welcome on our streets. I think the same is true for self-flying vehicles. You already have a homing beacon, which is your phone. So I would say that one of the future scenarios, we don't offer this today, is come to where I am. You might be in a park, for example, or in the middle of the forest, and you just want something, and so you're saying, come give me what I just asked for, and you're not gonna be like, and here's my piece of plywood with the X on it. I think that it doesn't scale super well, so it's not a crazy idea, but I would rather pick things, especially when machine learning is involved. Let's assume that this almost undoably hard thing can be accomplished. Because if we could, it makes people's lives easier and it makes the whole thing much more scalable.
Great. There was a question here at the front. Could we get a mic up to the front? And
Go ahead, I'll repeat your question.
There was another one over at the back, so let's take this one first. No, oh, okay. At the front here, this young lady here. Thank you.
Thank you. So going back to the cybersecurity comment that you were making, good guys are losing the cybersecurity game, and machine learning can be an answer. What do you think about hackers leveraging AI and machine learning technologies? A lot of the technologies that we have developed so far has been leaked and breached, and now in the marketplace for the hackers.
Right, so the bad guys get the stuff as well and turn it on us.
Yes, I'm not sure that machine learning is more amenable to hacking than other things, but I don't think it's less amenable to hacking either. So I think that that is a new field of cybersecurity that needs to be taken seriously, and B, you think that making your IT infrastructure hardened against cybercrime is hard? Try making a super complicated deep net, then the hackers are going to try to penetrate or use that deep net against you, and you're going to have a human understand that deep net and prevent against that hacking? No way. The only way that that's going to work is through some process of machine learning. And the reason I use immune system as an example is our skin does a pretty good job, but hardly a perfect job, of keeping the bad stuff out. And I think we're just going to need to acknowledge that in order for cybersecurity to really work properly, we need to have a system which is much more sophisticated than keep the bad guys out with some castle walls. That there has to be a constant process of antibodies in the digital world going, that's not right, let's fix that. Because if you have that working, then however they get in through a hack, on a deep net or through some more traditional means, you can still take care of it.
Yeah. There was a question at the back, gentlemen. Is the mic on?
For systems that operate in the physical world, how do you solve the data problem or the problem of limited number of episodes that you can run? Is there anything that can be done beyond model-based simulations?
Yeah, two answers. And you have to do both of these in our experience. The first one is you have to do an insane amount of testing in the physical world. Much more than seems reasonable, much more than most groups are willing to do. But I think that's what it takes. Waymo has driven more than 5 million miles on the physical roads with hyper well-trained drivers behind the wheel. For a long time, it was actually 2 drivers, not just 1. And that is an important part about it. And for many of those, a small fraction, but more than you might think, for many thousands of those 5 million miles, we were carefully constructing pathological situations where people were jumping out in front of the Waymo car dressed as Elmo and hiding in bags and then jumping out. We had people lying down on skateboards and zooming in front of very slow-moving cars to try to simulate the weirdest possible situations. So you have to test in the physical world, you have to do it incredibly carefully, and you have to create the worst situations you can while you're doing it under very controlled circumstances. In parallel with that, Waymo, I'm just using this as an example because it's top of mind for everyone, has driven more than 2.5 billion miles in simulation in the last 12 months. The really hard part is not having a simulator. Almost everybody has a simulator for their robot. It's having a simulator whose results somewhat transfer to the real world. If
Right.
you are a practitioner in
Right.
machine learning, you know how unsolved a problem that is.
Yeah.
But it is your job, if you're working in the physical world, to have a simulator, to use the simulator, and to be super focused on where it does and doesn't transfer as learning, so that you can sort of have a feedback loop between the actual physical testing and the simulator testing, so that the simulator gets better and you know which edge cases you're not covering in the simulator.
So I mean, the state of Arizona's just said, halt Uber, no more testing. I mean, should we actually be taking a pause here and just going back over all this stuff to make sure that it really works? Or you're saying, no, actually, we've proven it.
So I'm going to talk about Waymo, and
Okay.
you know, you can have Uber talk about Uber.
All right. I'll ask them afterwards.
I have personally stepped many times in front of
a
Waymo
Waymo.
cars, and I feel incredibly comfortable doing that. And I feel incredibly comfortable doing that because I know what testing we've done. And
Okay.
you know, people talk about regulating AI. Here's another secret, in case you don't know. We're not going to regulate AI. AI is counting. It's just statistics is about the fanciest I can like stomach us talking about AI. That's all it is. It's just counting. It's just counting. That does not mean that we won't regulate intelligent systems. But what we're going to regulate, what we have to regulate, are a shift from how we think about testing systems because they're strong enough. Think of a car and smashing it into a brick wall and making sure that the crash test dummy is safe.
Right.
Right? To testing the smartness of these systems. That is not a well thought out situation across sort of the public sphere yet.
Okay.
I think for many of our projects, like for Wing, like for Waymo, we are very much on top of that. But I think society overall has some thinking still to do about how do we regulate the safety of the system, but it's going to be at a holistic level, not going into specific parts of the code and saying, you have too much AI in there, get some of it out. It's just not going to be how it is.
One more question. There was one over there.
Hi. Yeah, so my question is about the agriculture that you're just discussed today. Google X's, or Alphabet X, forgive me, has done some agriculture work before, specifically vertical farming. And that didn't end up working. You guys ended up stopping that. So I have two questions, one of which is, what lessons did you take away from that you're now applying to this going forward? And what do you think has changed in the technology since you started that project that will make this work a little better?
The brief of it is vertical farming presupposes. So the way normal farming works, you get a lot of the capex for free. The sun is free, the dirt is free, at least some of the water is free, but you have to pay for the opex, the labor. Vertical farming is, what if we made a very expensive situation where the capex was quite expensive? You have to pay for your own sun lights, and you have to pay for the water, and you have to pay for the dirt. It's the land. It's very complicated and expensive, but then maybe you could get all the labor to go away. And it turns out that is a very hard trade to make anyway. And in particular, people have not really sorted out how to grow staple crops, which is really what it's going to take to feed the world better in those situations. And so that kind of automation was very heavy on infrastructure and relatively light on the kinds of automation that we're actually best at. So now that we're coming at it again, we're saying, wait, farmers are already doing a really good job in many respects. How can we, instead of totally reinventing farming, how can we go to the farmers and help amplify their expertise, shoring up things where they just don't have enough hands, where the labor isn't there to help them do various things that would make what they're doing even more sophisticated, rather than just saying, no, we're going to build a skyscraper, which is secretly a farm, which turned out to be hard.
Got it. You got to weed out bad ideas and harvest new ones.
Exactly.
So, ladies and gentlemen, please would you thank Astro?